Question 10. In the diagram, PQRS is a cyclic quad. KP is a tangent to the circle at P. C and D are points on the chord PQ and PS respectively, and CD produced meets RS produced at A. CA is parallel to QS. RC is drawn, and P1, angle P1 is equals to angle R2. So first question, 10.1, prove given reasons that S1 is equals to T2. So a lot of things happening in this diagram. But firstly, let's start off with P1 because they gave us, okay, P1 is equals to R2. So let's start there and move inside the circle. So immediately we can see P1 is there by our tangent. So P1 is equals to Q1. So to start, P1 is equals to Q1, and that's the tan chord theorem. And thereafter, what we can also say is that S1 is equals to, and S1 is equals to Q1 plus Q2. And the reason for that is your exterior angles of a cyclic quad. So if you look at the quad here, it's somewhat of a kite, but yeah, it's a cyclic quad in this instance here. Or the main reason for that is, so therefore S1 is equals to Q1 plus Q2. So we're slowly getting closer and closer to T2. So Q1 plus Q2, and that is exterior angles of a cyclic quad. And thereafter, we can say, and we can replace Q1 with P1. So therefore, S1 is equals to P1 plus Q2, right? And then if we have a look at T2, T2 is the exterior angle of that other cyclic. So if we highlight the other cyclic quad here of our triangle, at least, not of our, there's no cyclic quad here. So T2 is the exterior angle of our triangle. So R2, there's our triangle there. So here we can say T2 is equals to R2 plus Q2, exterior angles of a triangle. But they already tell us that R2 is equals to something, so P1 is equals to R2, but P1 is equals to R2, which is given. So if we sub that back in there, we can say T2 is equals to P1 plus Q2. And since they both equal to the exact same thing, so if we have a look here, we said that S1 is equals to P1 plus Q2. And then thereafter, we proved that T2 is also equals to P1 plus Q2. So therefore, S1 is equals to T2, which is equals to P1 plus Q2.